Here we go. We have a question, sorted subsequence of side 3. So you have given an integer array. We need to find any 3 elements in the array. So first we have array of I, then j, then k. So index should be like this. Note here is the output will print 1 if subsequence is valid. If subsequence not present, then we have to return empty array, then code will print 0. If subsequence invalid, it will print -1. So the note is not for us. So let's directly jump into the question. We have this example. In this, we have a subsequence 1, 2, and 3. So a subsequence exists. So we have to return these elements into a vector. So here output is 1 because this is valid. Here the subsequence is not present. That's why output is 0. So we have to do this in order of n time complexity and order of n space complexity. So let's build the approach. We have this and we want to create only 3 elements. We are only interested in 3 elements. So suppose the middle element is this. So we need to find the smaller element on left hand side and greater element on right hand side. So if we want to find the smallest element on left hand side, for this we need to find the smallest element for every element on the left hand side. So we create a stack here and we create a left array. Initially our stack is empty. For this value our stack is empty, so we have -1, no value present on left hand side. Then we add this value into our stack. So for this value we have to check, is the topmost element smaller element? Yes. So we place 1 here and add 2. Then we have 1. We need to check whether the topmost element is the smaller element or not. In this case it is greater. So we will remove 2. Now the topmost element is the smaller element. No, it is not. It is equal. So we have to remove this. So our stack is empty. We need to print -1. And at the end we have to add 1. Then for this one, this is equal. So we remove this one. Stack is empty. We print -1. Then add 1. For this, our topmost element is the smaller element. So we print or place 1 here. So for every element, we created the smaller element present on the left hand side. But we also need a element that is greater than the current element on the right hand side. Greater than the current element on the right hand side. So we create another stack, or we can empty this stack and use this stack only, and we need to find the greater element present on the right hand side for every element, for every index. For this, stack is empty, so we have -1. Then we add current element. For this element, the topmost element is the greater element, so we add 3 here and place 1. In this, topmost element is equal, so we remove 1. Now topmost element is greater, we want greater, so we place 3. Now we add 1. For this 2, topmost element is the smaller element, so we remove the smaller element till we get a greater element or our stack becomes empty. In this case we have a greater element, so we place 3 here. Then we add 2. For this element, topmost element is the greater element, so we place 2 here. So after iterating left from left to right and right from right to left, we again do a traversal and check for every element. For this element, we have to check whether there exists a element smaller than the current element on the left hand side and greater element present on the right hand side. So this index is correct. So for this, we have no element present on the left hand side. For this element, we have a element on the left hand side which is smaller, and we have a element present on the right hand side which is greater. So first we add this. This is the smaller element present on the left hand side, then the current element, then greater element present on the right hand side. So we have these 3. we add this value, then this value. So we have a answer, then we return our answer. So let's code this. First we have n, then we have a stack, left array, right array of n size. We iterate from left to right. While stack is not empty or topmost element is the greater element and we want smaller element. So that's why if the topmost element is greater or equal, we pop out and we want to fill on the current element. If stack becomes empty, we have to place -1, or not empty means the topmost element is the smallest element. We need to pick that topmost element. Then we push the current element. So after building the left array, we also need to create right array. Before that, I am using the same stack. So we first have to clear the stack. Then we fill our right array, traversing from right to left. Stack is not empty and stack topmost element is smaller or equal. Then we pop out. If stack becomes empty, we place -1, or not empty, we place the topmost element. Then we push our current element. After building the left array and right array, we have an answer. We traverse from left to right or right to left, totally depend on you. If there exist, if the element does not exist on left hand side or right hand side, we just continue. Else we are sure that a element present on left hand side which is smaller and right hand side which is greater, and the current element is the middle element. So first we pick the smaller element, then middle element, then right element, then we just break out and return our answer. Let's submit this, and the code is given in the description box. Let's talk about time and space complexity. Time complexity is order of n, and space complexity is order of n also. So if you guys have any doubts, feel free to ask in the comment section. Please give this video a thumbs up and subscribe to this channel. Thank you all for watching.